Okay, so we're going to be determining the Cartesian equation for the sphere with the centre here and a radius there. So you should have your little cheat sheet next to you so that you can look for the section that says something about circles. So if you look for the distance between 2 points, you'll see the D equals formula, and underneath it says if P, X, Y, Z is a point on a circle, its radius is going to be, and then there's a formula underneath. So for those of you who don't have it next to you, the formula that we get for a circle is R squared is equal to X minus XC, and we'll talk about what that is in a second, plus Y minus YC squared plus Z minus ZC squared. Okay, where R is the radius, and the things with the C's next to them, XC, YC, and ZC represent the center of the circle. Okay, so if we've got our center is here and our radius is there, all I need to do is chuck it into this formula here. So for A, I'm going to start by writing my formula. And then I'm going to substitute our values in. We've got that R equals 9. So that's going to be 81. Then I've got that the center, the X coordinate for the center is at -3. So the minus -3 will become plus 3 squared plus Y minus 7 squared plus Z minus 2 squared. Okay, and that's all we need to do for that one. Get it into that form. Now, it does say Cartesian equation, but we're happy with that for now. So instead of having the 9 squared, we'll replace that with the 81, and then this would all be the same up to there. Okay, B. Determine the Cartesian equation for the sphere that has one point there, 1 point here, as the end points of its diameter. So if I'm thinking about my sphere, I've got 1 point over here, 1 point over there. Okay, so I can use what I know to find the midpoint of this, which is another way of saying the center of it. So all I really need to do is think about what I have and what I want. Now, if I've got two different things and I want to find where the middle of it is, I take an average. So that means I add them together and I divide it by 2. So to find the midpoint, it's going to be equal to this one plus that one divided by 2. So 6 plus -2 over 2, comma, because this is going to return to us a coordinate, 12 plus 4 over 2, comma, 11 minus 1 over 2. So this will become 2. This one here will become 8, and the last one will become 5. So this thing, its center, its midpoint of the circle is there. Now I can use this information because now I found this point here that we'll just call C. So we can use this information to find the distance between the 2 points like you did in worked example 13. So distance is going to be equal to the square root of, so it'll be this one minus that one squared. So 6 minus 2 squared plus 12 minus 8 squared plus 11 minus 5 squared. Now, I could have used the other coordinate. It will give me exactly the same answer because the distance from C to B and from C to A is exactly the same. Okay, so 4 squared is 16, plus this one is also 4 squared, so plus 16, plus 6 squared is 36. Yep. All right, so then these two combined will make 32. 32 plus 36 will make 68. Okay, so now I'm going to think about what I have and pop it into our formula because we want the Cartesian equation, which means we want it in this. So if this is the distance from the center of the circle out, that's the radius. So here our radius is equal to the square root of 68. So that means that in my formula, when I square this, r squared is going to be equal to just standard 68, not the square root of 68. So once I have that, I can pop everything else back into my equation. So I'm going to have 68 is equal to x minus 2 squared plus y minus 8 squared plus z minus 5 squared. And that's going to be the Cartesian equation of this information that we've got right there. Okay, so next one we want to do is C. We're going to determine the center and radius of a sphere with this Cartesian equation. So first thing I'm going to do is I'm going to just, I'm going to copy this bit so that I can do this down below. Okay, that didn't work. Whatever, I'll just do it the old school way. Okay, so here is the equation that we are given. So x squared plus y squared plus z squared minus 12x plus 4y plus 8z plus 20 equals 0. Now we want to get this into our equation of a circle, which means we want to have some sort of r squared is equal to, and then we want to have it in terms of x minus wherever the center is squared. Now we need to do that for all components of this, so we're going to do the same thing for the y's and the same thing for the z's. Riveting, I know. Okay, so I'm going to first group together my components of x. X squared minus 12x. Then I'm going to do the same with y. Y squared plus 4y. Then I'm going to do the same with the z's. Z squared plus 8z. And then I'm going to just leave the 20 alone for now. Okay, so next thing I want to do is I'm going to be completing the square for each of these to work out what needs to go in the bracket. Now, when we're completing the square, it's not a hard process, but people forget all the time. So all I have to remember is the number that's going here is going to be half of b. So this is my b value. So half of that is going to be -6. Now we do that because in our bracket is going to end up having x minus half of b. That's what we're going to have in our bracket. Because when I multiply it out, x times x makes x squared, x times -6 makes -6x, -6 times x makes -6. So far, I've got that component, which was this. These two, when I add them together, will make that. The only thing that's really different here is when I do -6 times -6, that will make +36. So currently, this has got an extra 36 compared to what we had originally. So I need to take away 36, because if I do that and then I minus the 36, I can say that this statement is equivalent to this statement at the top. Okay, so now we're going to do the same thing for our second one, our component of y. 2 squared will make 4, so I need to minus 4 from that one. Plus, now we can do our z component. 4 squared will make 16, so I need to minus 16. Okay, so we're getting closer. So first thing I'm going to do is I'm going to group together all of these. So currently I'm at -40, -56, plus 20 will make -36. Okay, and then I'll have all my components of x and y and z. Next thing I'm going to do is take this to the other side to make 36, and then I'll have this same stuff here, and then that will be my final solution. Now, if it did ask you what the radius was of this circle, all I'd have to do is square root the 36, and then that would give me that the radius is equal to 6. It does actually ask me to do that. Isn't that amazing? Well, lucky for us. The other thing that it asks us to do in this question is determine the center. So the center is going to be located, remember it's the inverse of this. You can also think about solving each bracket for 0. So 0 equals x minus 6, meaning that the x has to be 6. So 6, it's the opposite of whatever's in the bracket. Minus 2, minus 4. What's in that bracket? Yeah, it must be a 4. Minus 4. So that's where the center is, and that's the radius.